Welcome to week 2 of Math 320. Last week we left off on talking about the order structure of the real numbers and the rationals, meaning how we can compare two real or rational numbers by size. We also discussed the Archimedean property of the rational numbers, some consequences of which are: first, there are no infinitesimally small rational numbers. Second, between any two rational numbers, there is a third one, showing that there are no sizable gaps among the rational numbers. This week, we will discuss how, in spite of the lack of sizable gaps, there are still holes among the rationals. We will also discuss how the set of real numbers fill in those holes. To do so, we need to begin by codifying some concepts. Most of these should be intuitively obvious. We'll leave the less obvious ones to next week. First, we will talk about the concept of maxima and minima of a set of numbers. The definitions are exactly as you may expect. The subtlety lies in the fact that not all sets have maxima or minima. Secondly, we will talk about the concept of upper and lower bounds of a set of numbers. It is important to note the significant conceptual difference between upper bounds and maxima. We will next introduce the concept of a cut and how this captures the incompleteness of the rationals. And we will conclude this week with the completeness axiom of the real numbers and a few consequences. There are several equivalent ways of expressing the notion of completeness of the real numbers, and the formulation I will give here is slightly different from that of your textbook. The end result, however, is the same, as we will see in lecture 5 of this week. If you want to see the same material written down, this week and next, the topic of our discussion will largely be covered in pages 20 through 26 in your textbook. That's it for this week's overview. I'll see you in lecture 1.